2 to 4 years of experience in data engineering and you are still not able to clear interviews, the problem is not tools. The problem is depth. In this video, I will break down exactly what companies expect from a 2 to 4 years experienced data engineer topic by topic. Okay, this will be not a beginner content. This is interview depth clarity. Okay, so agenda would be this. We are going to look at the different topic. For example, we are going to look at the SQL, PySpark, data warehousing, orchestration, cloud architecture, right? And then at the last, we will seeing a difference what they expect from 2 years experienced data engineer and 4 years experienced data engineer. Okay. Okay. So what interviewers actually evaluate, right? So they want to know whether can you debug production issues, right? Do you have debugging skills or not? Do you understand distributed systems, right? Well, if you have understanding of distributed systems, right, then only you can you can do performance optimization, right? Can you optimize cost, right? Optimization directly related to, right, query optimization, right? So if you are able to optimize query, right, you are going to optimize cost, right? Can you experience production failure, right? If there's some failure, can you track down the root cause, right, root issue? And if you are able to track down root cause, right, then it proves, right, you have production issue, right? So they're not hiring someone who knows syntax. See, 1 to 2 years experience engineers, if they know syntax, well and good, right? But since you are experienced now, they're not looking for someone who just knows syntax. They're hiring someone who understands systems, right? Okay, so let's look at the SQL, right? This will be your elimination round. If you are weak in some other technologies, for example, if you're weak in Python, they are still going to give you a chance. But if your SQL is weak, you are out at that time only. Okay, because believe it or not, SQL is one of the most used technology in for a data engineer in his or her day-to-day life. Okay, so let's look at these topics, right? So what they expect, so they want you to know join, right? They just don't want, they are just not looking at syntax. They want to know what kind of joins are there, which join do you want to use for given scenario, whether you will use left, inner, right, and other kind of joins, right? Whether you are able to explain the differences between these, when you are going to use, right, on what scenario you are going to use which one, right? You have to have deep understanding of these all things. Then they will ask you aggregation, for example, group by, right? When you are going to use, what can be the advantages of this one, when to avoid this one, right? Then they will look at windows function. So they're just not looking for syntax. They want to know whether you understand this one in depth or not. For example, they might ask, okay, why when to use rank, dense rank, right, and row number, right? In what scenario I'm going to use these three, and what can be the advantages, right, of using row number over dense rank and rank over dense rank, right? These scenarios you should know. And then the next thing comes CT, right? Common table expression, right? CT. So why do we consider CT over subquery, right? uh, why there was a need to use CT when we had subquery. You should be understanding these all things. They should be asking you all of these things, right? And then they might ask when you are going to use having, right? In what scenarios we are going to use having, when you are going to use where condition, right? These two differences you should be uh, aware of. Then comes the query optimizations, right? So how you are, so they might give you some query, right? They might give you some table, let's call it table, and then might give you some query, some select query, right, from table. And obviously there would be some more clauses to it. It can be group by row, something like that. Then might ask, okay, how I'm going to optimize this query to perform it better than the than current state, right? You have to be aware of these things. Okay, then executor on order, right, and index of events. For example, they might give you a query, select I'm just giving you simple query, right, from table A and there will be where conditions. Consider where column A is equal to some value, right? Let's some value. So they might ask you, okay, for this query, what would be the query execution order, right? Which one would be executed first, then which one would, then what would happen next step, right? So you should be able to explain query, right? Explain the execution order. You should be able to understand this, right? Okay. So differences between, they will ask, okay, differences, right? I say difference between rank, dense rank, and row number. You should be able to explain it with example, right? And which scenario you're going to use this one, right? Then they might ask you to find duplicates, right? How we are going to use duplicates? Are you going to use group by to find the duplicates? Are you going to use window function, right? In which scenarios group by, using group by is enough? In which scenario window function is necessary, right? What would be the advantages? Which one is more performant, right? So you should be able to explain it, right? Then they might ask you to find, these are SQL problems, right? They will be giving some table, and then they might ask you question to find consecutive records. Then they might ask you to find top n per group. These are just patterns, okay? You should be able to understand, okay? Top n per group, for example, they might give you department, and then employee, and then salary, right? And they might ask you find top 3 employee with highest salary per department, okay? So how we are going to tackle this, whether you are going to use group by or you are going to use window function, right? This explanation you should be able to explain, okay? Then they might ask you why is query slow. This is nothing but query optimization, right? Okay. So how would you optimize large tables? Whether you will use partitioning, right? Whether you will split the tables into two different table based on the rows, the columns, right? So these all things you should be able to explain. It is nothing but data modeling problem, right? Data modeling problem. Okay. So these all things, right? These all things, right? You should be able to explain with depth, okay? What you should be able to understand: execution order, uh, partitioning, aggregation costs, right? Sorting impact. What would happen if I'm sorting my data, right? If I'm ordering my data, what is the impact? Data shuffling is happening there, right? If I order data, if I order something, right, sort my data shuffling is happening, going to happen here. So how it is going to affect my cost? You should be able to explain this thing. So if you don't know how your query runs internally, right, they are not going to consider you as a senior. They will still consider you as junior, right? So you should be able to explain these all things. Okay, let's move to the next one, right? So if their JD contains PySpark, which is going to be there for most of the time, because nowadays PySpark is like one of the most important tool for warehousing. Okay, for data transformation, data handling. Okay, so again, since you are targeting 2 to 4 years, right? Mid-level, mid-senior level, right? So again, syntax is not going to work here. You should be able to, for example, if I ask you RDD versus data frame, right? You should be able to explain the difference, right? Right. Okay. And for example, this lazy evaluation, right? What is lazy evaluation? Why Spark uses it, right? Then advantages, right? You should be able to explain this one. What is DAG, right? What's its function? How a Spark use it, right? Then Again, there would be what is transformations and actions, how would you distinguish. So they might give you what is read, whether this is a transformation or action, what is group by, right, what is partition by. So you should be able to explain the differences and why this is the action, right, why this is action and why this is transformation. You should be able to tell with explanation. Okay, then next would become kind of transformations, right, which is narrow, which is wide, why to avoid wide transformations. Like you cannot avoid wide transformations in each cases, but if it is avoidable, why you should avoid it, right, what's the reason to avoid it. Okay, and for example they might ask quales versus partition by, right, partition by, right. So which one of this is wide, which one of this is narrow, right, which one you prefer if you want to decrease the number of partition. For example, if there are four partitions and I want to decrease it to two number of two partition, which of this is going to use, whether it is quales or whether it is partition by. Why you are still, for example, I can use both, right, partition and quales here. But why I will, if data order is not necessary, right, then why I'll prefer quales, right, why I'm avoiding partition by. So this you should be able to explain this thing, right, because partition by will cause data shuffle. Okay, and shuffle is one of the most costly operation, right, because we are moving data across executors to sort it, right. We are doing some operations which will be pulling data from all of the executors, then data will be moving across executors, right, partitions. So that's why it's very costly, right. So if data order is not necessary, we would be using quales is narrow, it's narrow, and shuffle is wide. Okay, well and good. Okay, and for example, if I have two partition and I want to cover it to make it to four partition, which one going to use, whether it's college or partition, right? So obviously college can only decrease number of partition. Okay, college cannot increase number of partition. So in that case, college is out, right? We will be using partition. Okay, so what they expect you to know, right? They expect you to know partitioning, right, table partitioning, what columns, which column, how to choose columns, right, how to choose columns to partition, how you will decide it. So with it can be on join column that you are going to use join the table, right, or if you are using some filtering columns, right, on which you are going to use filters. You can, there are multiple cases there, but I'm just giving one or two. So repartition by quales that I saw, right, repartition it causes data shuffle. This is very costly operation. Quales is narrow transformation, right. Okay, in what cases we can use, why to consider quales over repartition if that satisfies the condition. Okay, what is broadcast join, right, in, in what cases we can use it, right. Okay, so broadcast join can be used when we have a small table, right, then we can broadcast this. Okay, and this can be used in join, so this will be making our join much faster considering. What is data skew, right. Okay, so data skew, how you will handle this. So data skew is nothing but consider we have a table. Okay, we have a table and we have a join column. For example, a column on which we are joining, for example, we have country column. Okay, country column, and it has four: India, Japan, then let's take another small country. uh, let's say, I don't know whether Jordan is a country or not. Let's take example Jordan, like three example. Okay, and So consider India has a record of 1 billion records here. Okay, for uh, joining ki Japan we have only 1 billion record. Let's even consider 1k record, right? And for Jordan also we have 1k record. So here you can see India, record of India is much higher comparatively than Japan and Jordan, right? So this is nothing but data skewness, right? One of the columns data is much higher compared to other, right? So this is not going to cause data skewness, right? So how you handle data skewness? So there are multiple techniques. One of the techniques is salting. You can read about these things in detail, obviously. So you can use salting some, okay. Uh, Okay, then we have caching, right? Data caching, how, when to use caching, right? When to avoid it, how will how will you tune your memory, not your Spark's memory, okay? Okay, so your Spark, for example, let me tell you, give an example, okay? So you have a Spark job, okay? A Spark job, takes, it process 800 GB of data, okay, and it's failing without of memory error. What will you do? What will you do? Okay, so you can start like something like that. Okay, I will check the partitions, I will check for data skew, I will, if there is a small table in join, I'll broadcast it, I will avoid collect a statement if there is in between, right? I will increase executor memory, and if there are some file types, for example I'm using CSV, JSON, then I will use Parquet in place of that. So these are some of the expected answer, right? But these are the not only answer, right? This will again depend on the scenario. Okay, so if you cannot explain shuffle, right? If they're asking you shuffling and all, and if you're unable to explain it, they are not going to consider you for senior role. Okay, you are still in junior position. Okay, let's move to the next topic. So data warehousing, right? So obviously this you have to be strong in this one, right? So most right now in market we have three warehouses that is being used most: Snowflake, BigQuery, and Redshift, right? We have again Azure, something from Azure too, but these are the three are the most widely used. Okay, so you should be able to explain a few things, right? Partitioning and clustering, how you will cluster your data, right? Clustering is nothing but uh, I will skip this one for now. I will talk this one in detail in when I'm discussing about Snowflake. But yeah, so how you will on what keys you will partition, right? Keys means column here. Partition or cluster your data, right? How is this? What is the scaling, right? A scaling, where how the scaling, for example, how does it work? What are the architecture? For example, if they might ask you architecture of a Snowflake, just to understand whether you have hands-on experience or not, right? How you will optimize cost, how you will optimize cost in, for example, how will you optimize cost in Snowflake. So how you will choose, how you will choose the correct warehouse size, right? These all things, right? So these all things come under storage optimizations. Okay. Okay, so let's come to Snowflake, right? Let me discuss about Snowflake. So they might ask you what is warehouses, virtual warehouses, right? Micro partition, clustering. They are not looking just for definition. They are looking for explanation how this actually work here. Time travel and fail safe, right? Then they might ask streams. When do we use the streams? When do we use tasks? These are all things, right? Okay, and they might ask you a snowpark too. This is Snowflake flavor of PySpark, not exactly PySpark, but the syntax matches exactly like PySpark, so they call it Snowpark. Okay, so they might ask you, okay, what is how partition pruning, right? Pruning nothing means partition filtering. For example, I have 100 partitions, right? And I will select the columns on which I'm going to partition such that my data is not going to be my table is not going to be scanned fully, right? For example, if I have some date column, for example, I have some date column called as record date, right? And I have clustered my table, partitioned my table on this one, right? And if I write query something like that, where record date is greater than 20250101, right? So what Snowflake will do, it will go to the micro partitions and it will look for the cluster. Okay, if you look for the blocks, okay, where we have data starting from here, right? And it will skip, for example, I have data in this one and this one, right? So it will not scan these two blocks, it will scan these two blocks and give us the data, right? So this is nothing but partition pruning. Okay, so you should be able to explain this thing. Okay, in case of BigQuery, again the same thing. See, concepts remain same, right? Only few things change here and there. They might ask partition table, clustering, slots, partitioning, pricing model, how would you optimize a query and all, right? In case of again Redshift 2, the distribution key, the sort key, how will vacuum a table, how will analyze the table, right? So warehouse knowledge shows you understand storage and performance, right? It proves that you have hands-on experience and you have not gone just through some books and gone through some syntax and you are here for interview. This proves that you have hands-on experience. Okay, next comes the orchestration, right? So if you have everything in place, how you will schedule, right? How you will schedule jobs, right? These are all things. So most probably right now, Airflow is most widely used. Somewhere we are still using Dagster, Prefect, and then there are some in-house tools too, but mostly in market right now we are on Airflow. Okay, so you should be able to explain DAX and scheduling. You should be able to know which operator, right? Which operator to use and when to use. For example, if you're using some if you are creating some task related to AWS, you should be able to name operator which you are going to use, right? How you are going to create dependencies in series, in parallel, right? How you're going to do backfill of the data, right? How will monitor, right? What happens if job fails, right? What happened in that case? Whether you will send alert, right? Alert, retry, these are all things you should be able to handle, right? How to run, for example, if there are multiple, so there are tasks, right? Task 1, task 2, task 3, task 4, these all are in series, and for example this task 2 failed, right? How I will let unblock other task, right? So whether you can go and mark it successful, right? Then next task will start running automatically. And if you think, okay, this was failed by some error and you have fixed it, and you can just go and clear it, and then the task will start from here. These all things you should be able to explain. Okay, and then they might ask you how to manage production failure, how you would pass data between two tasks, right? Pass data between two tasks, right? Two tasks. You should be able to explain this thing. This is where they judge your production experience, right? Because they're not here, they are not just looking for your orchestration experience, they are looking exactly whether you're able to explain or not, right? And it proves, okay, you have hands-on experience, then only you're able to explain these things. Otherwise you will not be. Okay, so focus also gives put some focus and effort here. Then right now this is one of the most hot tool, right? DBT, that is used being used in most of the projects right now. Okay, so you should be able to explain models, materializations, okay, which incremental models, whether you are going to use append, merge, delete, insert, right? You should able to explain it in what cases you can use append, in what cases you are going to use merge. So if we don't have any primary key, right, or combination of keys which makes a record primary, obviously we will be focusing on append. If we have some primary key or some combination of keys which helps us uniquely identify the record, right, then we are going to use merge. Okay, then again, uh, what are the advantages of using it, what are the disadvantages? Obviously merge is costlier compared to append, right? So all these things you should be able to explain. A snapshots, right? A snapshot, dbt snapshot, right? Dbt snapshot gives you a way to drive SCD type 2. Okay, and then dbt test. So how, for example, you can test using dbt test, you can test data freshness, and then you can write range test. Okay, whether my data is, some columns data is in this range or not, right? These all tests you can do using dbt. And then they might ask, okay, when you can run manual SQL, right? You can directly schedule some SQLs. Why you prefer dbt, right? So you can talk about modularity, right? Dependency. So dbt manages dependency for you, right? These all things are again multiple advantages of using this thing, but you should be able to explain, right? Okay, so let's move to next topic, cloud knowledge, right? Again, they are not looking for all three. You should be able to, you should have experience on one of these. Okay, so you should be able to explain the storage services, for example, S3, AWS, GCS, IAM concepts, right? Roles, all these things, right? Managed detail services, for example, in case of AWS, right? What we have glue, right? You should be able to explain these all things. Monitoring and logging, how we will monitor, how we are going to monitor the log and logs, these all things, right? If something fails, some services fail, how are you going to do this thing, right? So for example, we have CloudWatch in AWS, which holds the logs for its component. Okay, you do not need to memorize services, right? You need to explain architecture. They are looking whether you have hands-on experience or not. If you don't have hands-on experience, you might not be able to explain the things, right? Let's move to next topic, end-to-end pipeline. Okay, so this is where experienced data engineers shine, right? Okay, so let me give you something. If I give you an API, we have a API source, okay, and I ask you to design a pipeline. Okay, end-to-end pipeline. For example, the ingestions to the transform processed layer, right? For example, so how you will do, right? So you can come like this one. Okay, I will pull the data from API using Python. I will in the same script, right? In the same script, I will pull the data. I will do transform the data. I will then in the same script I will write it to, for example, a Snowflake, right? So using one single script, I am doing all things: pulling the data, pull, transform, and then write to Snowflake, right? Right? This can be one of your solution, right? But is this the correct example? Are they looking for something like this one, right? No, this is not an optimized way to do this, right? Because if your script fail, right, all of your data is gone, right? And this is too tightly coupled. So how you are going to explain this? Okay, so you can say I have API source. Okay, and for example, if we don't have any tool, right, which provides a connection to API, so I can write my custom Python script here. This will do nothing but just pulls data from API. This is only task of it. Okay, this is pull the data API, then keep on putting it on S3, dumping on S3, right? We have data in S3. Okay, then from S3 I will use, this is a Snowflake, raw layer. Okay, so from the Snowflake, from S3 I have multiple ways to insert data into Snowflake, right? For example, I can use copy, directly copy, right? Or I can use uh, a snow pipe, multiple way, right? So these all again depend, right? Once the data is in Snowflake layer, I can use dbt to create processed layer. Means I am going to do some cleaning over the raw data, right? And then again in the same I'm going to use dbt again to process it, right? In the processed layer, this can be again summary or dimension or facts, right? This can be one of the way. Obviously this is not the only way, this is one of the way, right? So you should be able to explain, okay, why you are using S3, why not some other technology, right? Why not directly dump into Snowflake from Python, why you are dumping to S3, right? This should be able to explain. Okay, so you should be able to choose your ingestion script, landing zone, right? Where processing, warehouse load, orchestration tool, and they will ask you, okay, so this is one task, this is two tasks, this is task 3, this is task 4, how you're going to schedule this, right? How you're going to schedule this one out. So you can say I will create airflow DAG with all these tasks with dependencies, right? Then they will ask you about alerting. If one of the tasks fails, what we're going to do, whether just alert it and leave it, or we are going to handle it, how you're going to handle it, right? Failure handling. Then optimizations, cost optimizations. Okay, if you're going to run this query, how many times you're going to run this query, on what uh, you know what would be the warehouse size, what do you expect, how costly would it be, right? This all you should be able to understand. So this is where, right, this is exactly where they will get an idea whether do you have hands on or not, right? This is exactly where they should be able to tell you. Okay, so you should be able to design select components, select next component, select next action, right? These all things, right? So there is no correct or wrong answer here. Okay, so why you're using S3 here, you should be able to justify it. Okay, I'm using S3 because I have, then once the data is in S3, I can use this tool, I can use the Snowpipe, I can use copy command, whatever, right? So you should be able to justify it. Why I'm dumping into a Snowflake layer, why I'm not directly doing my cleaning of data directly here only, and then loading into directly into processed. Why I'm putting data in one more layer, right? You should be able to tell these differences. Okay, so you should be able to justify it. Okay, let's come to the next topic, right? 2 years versus 4 years, right? So what they're expecting, right? So 2 years write queries, right? So if I just take a 2 years, right, and 4 years, so you will 2 year guys, they expect them to write queries, right? And the 4 years guys, they don't expect just to write queries, right? They want you to take the already existing queries and optimize it. Okay, for example, let me take another thing. 2 year guys expect them to run some Spark job, right? A Spark job. They can write some basic Spark jobs and run it, right? But for you have to tune it. Okay. So 4 year guys, they expect you to design systems, right? As we talked about end-to-end pipeline design, right? You should be able to design pipeline, choose components, right? Justify it. Why you should be knowing advantages and disadvantages of selecting that component, right? Right. So this is your correct your full path if you are preparing for data engineering interviews. Okay. So I will just say, okay, stop preparing tool wise. Okay, don't focus on tools. Start preparing depth wise. Your foundations should be very, very clear. You should be able to explain why you are choosing this component over that, what are the advantages, and what would be what we are going to do in case of failure. Okay, so if you want, in next video I will break down real PySpark mock interview questions and how to answer them confidently. Okay, I hope you have enjoyed watching this video. You have understood what you should be following, okay, what depth is required to crack the interview. If you have any question, just let me know in comments. Okay, thank you. Bye bye.